Let's look at power series solutions of second-order differential equations. For example, find the first four non-zero terms in a power series expansion about x equals 0 that is a general solution to the differential equation y double prime minus 6xy equals 0. Give an answer in terms of a0 and a1. Since we need only four terms, we don't need a general formula for a sub n. That would be an unnecessarily complicated way to solve the problem, and in fact, there are some answer guides that show you to do that. Let's talk about power series solutions of second-order differential equations. For example, find the first four non-zero terms in a power series expansion about x equals 0 that is a general solution to the differential equation y double prime minus 6xy equals 0. Give an answer in terms of a0 and a1. Since we need only four terms, first four non-zero terms, we don't need a general formula for a sub n. That would be an unnecessarily complicated way to solve the problem. And in fact, there are some textbooks that advocate you do that. Well, don't. Waste of time. Here's our differential equation, y double prime minus 6y equals 0. We're going to use this substitution since we're looking for power series. Y is just going to be the sum of a sub n x dn as n goes from 0 to infinity. In other words, it's going to be a0 plus a1x plus a2x squared, etc. Take the derivative. We find that y prime is a1 plus 2a2x plus 3a3x squared plus 4a4x cubed, etc. Take another derivative. We get y double prime equals 2a2 plus 3 times 2 a3x plus 4 times 3 a4x squared plus 5 times 4 a5x cubed, etc. Okay, and now let's just plug those into this differential equation. So we have y double prime, this is y double prime, minus 6xy, so in other words it's going to be minus 6x times y, that's y, equals 0. So this again is y double prime. We're going to distribute the 6x, so again distribute the 6x and we end up with this. This is from the previous slide. I haven't done anything different here. So now let's combine coefficients. So the constant coefficient is 2a2. That just comes out front. The coefficient of x is going to be 6a3 minus 6a0. Okay, you combine those and this is what you end up with. The coefficient of x squared is going to be 12a4 minus 6a1. And that's where we get this. In the same way, the coefficient of x cubed is 20a5 minus 6a2. Coefficient of x to the fourth is 30a6 minus 6a3, etc. Okay, now we just match coefficients. Notice the coefficient, a constant coefficient on the left side is 2a2. Constant coefficient on the right side is just 0. That means 2a2 is 0, which means a sub 2 equals 0. How about the coefficients of x? Okay, on the left side is 6a3 minus 6a0. On the right side, I don't see an x here. Do you see an x? There is no x. The coefficient of x on the right side is just 0. Therefore, 6a3 minus 6a0 just equals 0. In other words, 6a3 equals 6a0, so that a3 equals a0. Now let's match the coefficients for x squared. 12a4 minus 6a1 equals 0. That means 12a4 equals 6a1. In other words, a4 equals 6/12 a1 or 1/2 a1. And believe it or not, we're done. We wanted y equals a0 plus a1x plus a2x squared, blah, 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 blah. But we wanted to express that just in terms of a0 and a1. Well, a2 is 0. We saw that a moment ago. a3 is equal to a0, and a4 is equal to 1/2 a1. So we can write the first four non-zero terms of the power series in this way. Y is a0 plus a1x plus a0x cubed plus 1/2 a1x to the fourth. Again, we just chose the first four terms. You could go on ad infinitum, but those are the first four non-zero terms.